Okay, hello everyone. Good afternoon. Biggest thanks for joining this Saturday evening. But before we dive in, I'd like to talk about what makes our community so special, and I'm proud of this. This is super friendly and inclusive space, and we are all here to learn from and support one another. Without lifting each other up, we can't grow up truly. We ask that you keep all interactions respectful, positive, and only professional. Our goal is to make everyone feel safe and comfortable participating and asking questions. Feel free to ask any questions in our chat. But if something doesn't feel right, please don't hesitate to let me know immediately. Feel free to ask me in direct message. This event session will be recorded. Let's start. And a warm welcome to the third event of our AI Quantum Clubs, happening as part of DevFest 2025, hosted by Google Developer Group Ahlen and Google Developer Group Heilbronn. My name is Anna Muzykina. I'm organizer of Google Developer Groups Ahlen and Heilbronn, and today I'll dive into something new: hybrid cryptography, a way to keep our data safe from future super smart computers called quantum computers. Imagine a quantum computer as a super fast puzzle solver that could unlock your data if we don't use right locks. But we should use them. We will mix old, trusted logs with new ones to make sure everything stays secure, especially for AI computers that learn from examples like recognizing pictures and quantum systems. Let's get started. Let's look back at our journey to get ready for today. At our very first event, we talk about post-quantum cryptography, which are new ways to log data because quantum computers, machines that use tiny pictures to solve problems super fast. An idea from scientist named Richard Feynman in 1982 might break our old laws. We learned about a problem called Shor's algorithm from 1994, which could unlock old codes like RSA. In our second event, we explored NIST standards. So last week we explored deeply these standards where US group picked three new logs: Kyber for shining secrets, Dilithium for signing papers digitally, and Sphinx Plus for keeping things safe long term. All decides after a contents from 2016 to 2024. And today we will mix these new logs with old ones using hybrid cryptography. Next time we will apply this to keep AI safety. Here's our plan for today. Like a map for a treasure hunt. First, we will learn why hybrid cryptography is important, why we need to mix old and new logs. Then we will see how it works with simple pictures. And we will talk about benefits. After that, we will explore with our special guest, Sayed Amir Hamza, how it works in real life project, how it was successfully represent. So let's start. What is hybrid cryptography? Cryptography shortly is the core strategy for quantum resilient system, combining classical key exchange like elliptic curve Diffie-Hellman or shortly ECDH with post-quantum cryptography like ML-KEM or Kyber shortly. It generates dual shared secrets one classical for immediate trust, one post-quantum cryptography for quantum resistance, merged into a hybrid key for secure sessions. For newcomers, ECDH uses curve mass for fast key, vulnerable to Shor's. Kyber uses lattice for resistance. And later I'll remind one more time, amazing video to watch this, diving deeper into this concept. This belt and suspenders ensures if post-quantum cryptography has flaws, classical holds. In artificial intelligence, secures model updates. But why hybrid cryptography? So, hybrid cryptography is like wearing a belt and suspenders, two ways to hold up your pants. We mix old locks like ECDH with new locks like Kyber. This gives extra protection. If the new lock has a problem, the old one still works. If quantum computers break the old lock, the new one saves us. It helps us trust new methods because they are new and need testing. Experts like those at NIST, a US group that sets tech rules, suggest this because quantum computers might arrive quickly by 2030 and break our old ways. Imagine looking your diary with two different locks. One you have used for years and one that is brand new. Listen to what NIST said in 2024. Hybrid cryptography is a wise choice as we move to quantum safe systems. This means it's a safe step forwards, like using training wheels on a bike. It protects data with layers, so if one layer fails, another works. It's great for beginners because it mixes something familiar, old logs, with something new, post-quantum cryptography, letting us learn without worry. Think of it like having a backup plan for your project, extra safety. Traditional algorithms like ECDH enable secure key exchange and are battle tested in AI and cloud systems. They are efficient and trusted, but Shor's algorithm on quantum computers could break them. Hybrid uses ECDH as a reliable base, ensuring immediate security, while post-quantum cryptography takes over long-term defense for quantum AI communications. So this is exactly video I wanted to share with you. Last week we watched it, so feel free to rewatch it in your convenience.
Hi.
Okay. So let's continue. And in hybrid step, Kyber provides quantum resilience via lattice mass, standardized in NIST FIPS 203. It complements ECDH by adding layer unbreakable by Shors, ensuring AI data exchanges in quantum AI remain secure if classical components falter. This is another video I wanted to share with you. One second. So feel free to watch in your convenience.
Let's introduce.
Okay, let's move with hybrid key exchange concept. So hybrid key exchange starts with ECDH, generating a classical key, followed by Kyber for post-quantum cryptography key. They combine them into a hybrid key. This dual layer approach creates resilient session for artificial intelligence systems where the classical key provides immediate trust and post-quantum cryptography key guards against quantum risk in quantum AI. Let's zoom it up. So, hybrid adds safety by using two locks. One old, like classical ECDH, one new, like Kyber. So, if one breaks, the other holds. It works with old tech and new, like using an old phone with a new app. It builds confidence because we can test new codes while relying on old ones. It's perfect for AI safety, like keeping a robot's learning data secure or our own model data training insecure. And what about the rationale for hybrid? The rationale for hybrid, safest, pragmatic, post-quantum transition. Post-quantum cryptography, like Kyber, new flows possible despite NIST testing. Classical ECDH trusted decades. Defense in depth layers redundancy if post-quantum cryptography fails, classical holds. Backward compatibility integrates without rewrites. Gradual adoption. For artificial intelligence, secures quantum AI without halting development. NIST recommends hybrid pragmatic, balancing risk progress. Belt and suspenders resilience systems. Let's explore three benefits I found it in hybrid usage. Defense in depth, backward compatibility, and building trust. Defense in depth or dual protection. Classical ECDH provides immediate trust, proven security, and high speed for current data flows. Post-quantum cryptography, Kyber, provides quantum safety and resists Shor's algorithms, protecting against future attacks from quantum computers. Benefits of the late approach, dual coverage. If a future quantum computers breaks the classical ECDH, the post-quantum cryptography, for example, Kyber layer still protects the data. Conversely, the major classical system acts as a safeguard against any undiscovered bugs in the new post-quantum cryptography implementation. AI application in artificial intelligence, this hybrid method is used to encrypt sensitive assets like model parameters, ensuring both the speed from classical crypto needed for operation and the longevity from post-quantum cryptography required to protect the model's value over time. And as a conclusion, using this NIST recommended layered strategy is essential and not optional to build a secure foundation that protects valuable AI models from current threats and future quantum breaches. Benefit 2. Backward compatibility, seamless integration with legacy solutions. The hybrid architecture works with the existing elliptic curve Diff-Hellman (ECDH) algorithm without rewriting, adding a key encapsulation mechanism layer based on a modular lattice architecture. Gradual pilot implementation, scalable tests, continuous AI operation, quantum AI pipelines, encryption without interrupting training. As example, modifying a hybrid AI server with transport layer security support without downtime. Reduce costs without redesign. Risks and IETF requirements. Pragmatic enterprises, seamless post-quantum cryptography implementation. And last benefit, building trust transition, hybrid tests, post-quantum cryptography. Kyber real use alongside classical ECDH validates performance, no full risk. Classical proof, billion seconds, confidence post quantum cryptography. Community growth, shared reports, think accelerates adoption, developers see works. Artificial intelligence, faster quantum AI development, trust, hesitation reduces. And what about future of hybrid post-quantum cryptography? NIST updates and add algorithms, refinements based research. AI advancements optimize lattice parameters, Kyber, automate threats detection hybrid. Industry standards, IETF drafts transport layer security 1.4 formalize hybrid, easier deployment. For quantum AI, seamless integration. Hybrid secures quantum accelerate models, AI handling agility. Field accelerating, stay agile, lead evolution. Okay, and I think now it's time to see this project implemented in the real world. Meet our next speaker, Sayed Amir Hamza, Google Developer Group Heilbronn Organizer, co-founder of 4Kit Dev, and I am proud to meet these guys with their amazing realization of all these concepts in their project. So I will stop sharing. Hamza, feel free to share your screen
Is it
and let's
my
discuss
camera is
how
or
guys to realize this. Yes, when I met first time their realization, I was really deeply impressed because today it's area of my interests. Because really, artificial intelligence models, it's not our future, it's our reality, and quantum computers, it's also our nearest future. So, okay, you're welcome.
hello everyone.
Share your
Good
screen.
afternoon. Thank you, Anna, for giving me this opportunity, of course, to this platform to share my thoughts. And thank you, everyone, for being here, for managing your time, and yeah, for your enthusiasm for this. So I'm Syed Amir Hamza. I'm a researcher and co-founder of Forkit Dev. So over last few years, basically, I've been exploring how AI can adapt, learn, and stay efficient, and that same thinking basically applies perfectly to how we secure our system in the post-quantum era. So through these thoughts, basically we have used some quantum encryption in our system Forkit Dev. So let me share my screen to show you around that. Just a moment.
But meanwhile, just a small notification. How did you realize this hybrid? I'm sure that you used old mix with new algorithms.
Yeah,
In
yeah, of course. So we have
which
used
did you
this
choose?
SHA 512. So I'm just sharing my screen. So
Okay.
sorry. Can you see this
Yes,
screen?
perfect.
The
Yes,
quantum resilient?
yes.
So yeah, basically, how do you ensure our data or our intellectual property and our system remains secure, not just today, but for 10, 20, even for 30 years from now? So the challenge is that the in cryptographic foundation we have built our digital world on are about to face their greatest test. We are entering the era where quantum computers will fundamentally change what secure means. Let me show you around about the quantum computing threat landscape to understand it a bit more nicer. So, quantum computers work fundamentally differently from classical computers. While classical computer process the information in binary like with 0 and 1, but quantum computers use quantum bits, which we call also qubits. So it can be at the same time in both places, like superposition we call it. So this allow them to solve certain mathematical problems faster than the classical computer that we have right now. So the problem, many of our current encryption system, the ones protecting like our bank transaction, emails, our cloud data, rely on mathematical problems that are hard for classical computers but trivial for quantum computers. So two key algorithms threaten current cryptography is like Shor's algorithm that can break RSA and other public key cryptography exponentially faster. And then we also have this Groover's algorithm. So that provides a quadratic speed up for searching and attacking the symmetric encryption and hash function. But there are this thing also going on, the harvest now decrypt later reality. So basically what this thing happening here now, most of the critical insight at this, like the threat is not in the future but it's happening now. Why? Because the nation states and the sophisticated adversaries are already employing a strategy called harvest now decrypt later, so that they can collect the encrypted data now and storing it for 5 to 10 years or for 15 years, waiting for quantum computers to become like more powerful enough to decrypt it. And for AI companies, this is, yeah, particularly critical. The AI models we are building now, the weights, the training data, even the entire provenance chain, that could all become vulnerable in future. So what is Q day? Basically Q day is the day when a cryptographically relevant quantum computer, in short called QRQC, becomes powerful enough to break RSA 2048 encryption. So experts prediction are conservative estimates like by 2030 or 2040 like that, but these things are like the predictions is going like that, but as per the speed that AI brings us now, maybe that might be a bit much more faster than we are expecting. So yeah, we have less than a decade to transition our cryptographics infrastructure, but the question is what should we do now? So there is this like SHA 512, the quantum resistant. So we can talk about this. Here's the crucial insight that many people miss, but not all cryptographic algorithms are equally vulnerable to quantum attacks. So basically, this is here is the sample of SHA 512 hashing. So how does this work? Then if we input a data, then it has this output that will be 512 bits. So yeah, a tiny change in the input, so it can change the complete, it will give you the complete different hash on it. Then we have this public key cryptography versus the hash function. So to make it a bit more clear, the public key cryptography, those are vulnerable, are like RSA, ECC, Diffie-Hellman. So these are used for key exchange, digital signature. Then authentication status must be replaced with post-quantum alternatives. But on the other hand, we have these hash functions, SHA 256, SHA 512, SHA 3, only attacked by Groove's algorithm. even in the quadratic speed up. So used for data integrity, digital fingerprints, and blockchains. But why SHA 512 matters in the quantum era? Because this is a cryptographic hash function that produces a 512-bit 64-byte hash value. It's part of the SHA-2 family designed by NSA and published in 2001. Key properties: one-way function, so it's easy to compute a hash from data, impossible to reverse. Collision resistant, extremely difficult to find two inputs with the same hash. Available hash, so a small change in the input creates completely different hash. Deterministic, so same input always produces the same hash. Input resistance, so Groove's algorithm can search through n possibilities. This means SHA 512 bit output provide 256-bit effective security against quantum computers. 256-bit security is like there are yeah to 2.256 possible combinations. Even the most powerful quantum computer, would need billion of years to break this. But in the algorithm security comparison, we can see this SHA 512 is resistance due to its bits power. So here is the role in modern system and AI of this SHA 512. This is already widely used for blockchain, digital signature, data integrity, password hashing, certificate authorities. The key insight, basically, while we need to replace public key cryptography with post quantum alternatives, SHA 512 can remain as a quantum resistant foundation for data integrity and hashing. And why this is matters for AI? Because to verify the model integrity, so that it can ensure the model weights haven't been tampered with any other data or any other fine tune. Then we have this track provenance, so creates an immutable chain of model versions. Then generate unique identifiers, so that create fingerprints for each model, so that the developers also can verify their models that they have built, and build audit trail, so it comply with the regulations like EU AI Act law. So we have implemented this in our forkit dev. Now here I can show you a brief view on how like we have implemented this. So this is like forkit dev platform we are building to solve the fundamental problems in AI collaboration. So when we are uploading an AI model to this forkit server, then this model is generating a hash, and then there are these other developers or other users, they're coming and forking that model, and maybe building some other model by fine tuning with some other data set, so that if they upload, then it will get another hash, and it will be connected with the original model, so that it can create the chain how this model changed, by which user or by which companies, yeah, and which time. So it will have all the transparency about the changes that happened on the model. And these are due to SHA 512 hash, so it's creating an unbreakable and quantum resistant lineage. So the forkit dev approach here: transparent AI. So it's like our core principles, where every model has a verifiable history. Then privacy first AI, where it's only sharing, no raw data exposure. So as now the concern basically to share our personal data anywhere. So here through this system, we are not sharing the actual data. We are sharing the knowledge that that AI model learns from the data. So it is also sustainable because efficient model merging through knowledge distillations. And then it's also trusted AI. So because the audit trials we have, that is immutable. And democratic AI, so community governance through voting. So let's see how does it work. So we will when we are uploading a model then it's immediately hashed with SHA 512. So this creates a unique 512 bit fingerprint, which is stored on IOTA as a distributed ledger, and IPFS. It's also a distributed storage. So providing an immutable proof of the model's state at that moment. So other users can fork that model to improve it. Each fork gets its own SHA 512 hash, creating a verifiable lineage chain like Git for AI models, but with cryptographic guarantees if any changes happened. Then we have this community to vote on the model quality. So we have this playground where selected community members can check the model with the prompt and then can vote if the model is behaving as expected or not. So voting records are hashed and stored, which creates transparent governance. Then aggregate, which is like best forks can be merged back through knowledge distillation. The merge model gets a new SHA 512 hash, and the complete provenance chain is maintained, which mean basically when you have this task specific model, so we will have different task specific models. Maybe one model is specialized in the customer answer, and another model is specialized about the medical knowledge. So if we merge this both knowledge, and maybe we need this to use in the hospitals AI model to answer like the general thing. So it this model can have the idea of both about this medicals and also about this customer answer. Then we have this how we have integrated this SHA 512. So it provides basically the quantum resistance security through this workflow. So the model upload, this is 512 bit hash becomes the model's unique identifier. Then we have IPFS storage. So IPFS storage uses content addressing based on hashing. So the model is stored in a distributed network and can be retrieved by only with the hash, so only from the user who has that hash. And then we have the iota ledger. So this metadata is recorded on iota distributed ledger, so this creating a immutable provenance chain. Each entry is also hashed with SHA 512. Iota is based on tangle. And then we have used this for creation. A new hash is created extending the chain. So why this quantum resistant integrity? SHA 512 ensures no one can tamper with model weights without detection. Provenance, the hash chain creates an unbreakable lineage. Decentralization, iota plus IPFS means no single point of failure, quantum safe, even with a quantum computer. We are hoping by theoretically it's not reverse the hash is not reversible to get the original model. So it creates the collision like two different models with the same hash or forge the provenance chain. So here we have this sample code to use this. Anyway, we can skip this. So how we have got from Google Cloud to scaling this resilient infrastructure. So while SHA 512 provides quantum resistant hashing for integrity and provenance, a complete quantum resilient system needs more. So this is where Google Cloud Platform becomes the essential end-to-end resistant workflow we can see here on GCP. So the user, when they are uploading a model, this model is in forkit. So this model is getting the cloud KMS, confidential compute and blockchain nodes. So we can talk about this. The gap. Authenticity, basically SHA 512 proves integrity, but not the WH who created the model. So confidentially hashes are public. We need to protect the actual model weights. So forkitdef needs infrastructure that can scale globally and secure storage and management of cryptographic keys. So here the cloud sample of the cloud KMS implements the digital signature to prove who created the model, ensuring the authenticity and non repudiation that remains valid even against quantum computers. So here will be the model, then the model will be hashed by SHA 512, then it is going to have the sign from this cloud K- KMS, then it stores signature on IOTA IPFS. So confidential computing, yeah, uses hardware-based trusted execution environments (TEEs) like confidential VMS with NVIDIA H100 GPUs and confidential space to encrypt data while in use during the model training or merging. This protects sensitive IP and training data even from the cloud computer. So here is a sample. Basically this blue box is from this we can think about the environment. This is the con- con- confidential environment. So when the data is being trained to the AI, at that point the data is being decrypted. So it is maybe possible to attack at that point to have the information from the data, but this whole system ensures this, so that even we also cannot, the forkit or the Google, no one can have this access to the original data. So that's why I see the background. So the cloud provider or the external users, they will not be able to be in this environment. So blockchain node engine and decentralized infrastructure provides managed, reliable, and scalable infrastructure for the system decentralized co- components. And this includes fully managed node hosting, integration with services like cloud storage for IPFS backends, and high availability, ensuring the ledger is always accessible. So here we have the complete architecture. So user uploads the AI model and sent it to the forkit dev. Then from the backend on Google Cloud, it compute the SHA 512 hash, sign hash with cloud KMS, store model on IPFS, and record on IOTA ledger. Then we will the user will train the model. So training in confidential virtual machine, so the virtual environment machine, then data encrypted in memory, that TEE, new version gets hashed and signature. So the merging in confidential space, multi-party computation, and merged model gets a new hash plus signature, and the deployment model deployed on Vertex AI, endpoints secured with Cloud Armor, and all operations logged. Defense in depth layer, SHA 512, quantum resistant integrity, MLD DSA signature, its quantum resistant authenticity, confidential computing, hardware based confidentiality, and decentralized storage, so no single point of failure. Also, Google Cloud infrastructure for enterprise reliability. So here we have a sample code, and yeah, we're at the end. So yeah, we are at the critical inflection point. The quantum threat is real, the timeline is clear, and the tools exist today to build quantum resilient systems. So the key takeaway from here is SHA is quantum resistant and provides a solid foundation for data integrity. Forkit Dev demonstrates that quantum safe AI collaboration is possible today, and Google Cloud provides the enterprise infrastructure to scale these systems globally. And for so the call to action for developers, they can start using SHA 512 for data integrity in their application, experiment with Google Cloud KMS post quantum signatures, explore confidential computing for sensitive workloads, and for companies it's audit your cryptographic systems, plan migration to post-quantum cryptography, consider platforms like ForkitDev for AI collaboration. And for everyone, visit ForkitDev to see quantum resistant AI in action. Join the conversation about building secure and democratic AI. Help us to prepare for the quantum era. So the future of AI depends on trust, and trust the models are authentic, that data is private, trust the system will remain secure for decades to come. By combining quantum resistant cryptographic like SHA 512 with cutting edge infrastructure like Google Cloud, we can build that future today. So, yeah, visit Forkit. And yes, that's all. Thank you so much. Thank you so much.
Okay, biggest thanks for this real life project, because when we try something or just thinking about something, it's important to understand that someone realizes this. And I know, guys, you are very supportive, so everyone feel free just to searching Sayed Amir Hamza at LinkedIn, for example, contact him, and I'm sure that you will provide with everything, and you will give dose of advices and support everyone, I'm sure, in this. And of course, if you have any questions, feel free. But I see in chat we haven't questions, but okay, anytime. Anyway, feel free to ask any questions on our platform anytime. Yes, we try to be very supportive, support everyone, and now it's important era, and we need to be like not to be first. Of course we are not first, but we need to thinking about this. It's crucial, it's important. Artificial intelligence 5 year ago, we was thinking, oh no, it's our far future, but today it's our reality. The same situation will be with quantum computers. I searched last news and I understand that maybe it's not 2030, maybe it will be much soon.
Yeah,
2 years, yes, 2 years. So we should be ready for this, and it's good to have devices to start searching information. That's why we started this AI quantum clubs, and for kid, biggest things that you share it your real life example, and it's not in a secret. You're open, you ready support, give advices. And I know that your platform for everyone, yes, for
yes,
developers and for business,
yes.
everyone can contact you, developers and business owners.
Of
So
course. I know it's actually sometimes hard to get the ideas about everything, but when we are working with the sensitive data, or if that's somehow related with the sensitive data, then at that point, sometimes, yeah, of course, we need to be more precise how we can keep those data that's secure. Because yeah, of course, it's not just about the quantum, but even the today's AI, there also by itself it became a lot powerful. So Yeah, we it's better to know at least the basic security that can be like usable in
Yeah,
terms of that data.
hospitals, call centers, yes, of course, they get every day big of data and they try to hold this data in security. And yes, they need to start thinking about best ways, thinking about quantum computers attacks. Yes, of course. Okay, and thank you. Engage in this session. Hybrid cryptography, past quantum resilience system, combining classical trust, post quantum cryptography, strength secure quantum AI. Thank you for attending. This session is step toward shaping the future of quantum AI. We look forward to seeing you at the next events. We will have else few sessions at AI Quantum Clubs. We will try dive deeper, discuss more, gather more information. I try to find best videos, best speakers. This event session was recorded. I will share it later, so feel free to rewatch it in your convenience. Biggest thanks one more time for your time. I understand that it's Saturday, it's evening, it's not easy to find time to join in, but biggest thanks for your time and see you at our next events.